Hi, and welcome to this short concept bite, which explains the concept of enthalpy and shows the utility of state functions by introducing you to Hess's law. If you recall from previous videos in this course, a definition of the first law of thermodynamics is that in a closed system, the change in internal energy of the system is the sum of the energy transferred as heat and work, and I have previously said work includes anything where there is a uniform motion, such as expansion of a gas. Now, I expect most people doing a university chemistry course have already used the concept of enthalpy, but perhaps not the more fundamental internal energy. So what is the relationship between internal energy, which we can understand on a molecular level, and enthalpy? Fundamentally, enthalpy is a way of keeping track of internal energy when we are working in our everyday systems which are usually at constant pressure, and so this means systems which may be doing expansion work against the atmosphere. And so my change in enthalpy is related to my change in internal energy at constant pressure. If we take both our original definitions of enthalpy and internal energy, we can bring enthalpy back to a concept I'm sure you are all familiar with, that being heat. Frequently, calorimetry experiments are conducted where a temperature change is measured and then this is equated to the enthalpy of reaction. This relationship works because at constant pressure, the work done by a system is minus P delta V. And so doing a bit of maths, delta H at constant pressure is just Q, the energy transferred in the form of heat. This idea that the heat of reaction and the enthalpy are equivalent is seen in synonyms for thermodynamic processes, where a chemist would likely refer to the enthalpy of vaporization, whereas a physicist may use the term latent heat of vaporization. Just like internal energy, enthalpy is a state function. And the relationship between the enthalpy of a reaction is just the difference in enthalpy of the final and initial states. This relationship is called Hess's law, and when I worked with this concept, it will always be based around the equation shown here. The formal statement of this is the standard enthalpy of reaction is the sum of the standard enthalpy of the reactions into which the overall reaction may be divided. Tabulated values of enthalpies of formation and combustion are usually easy to look up, and so it is nominally simple to determine the enthalpy of any reaction we can think of. If the enthalpy of reaction is positive, the system absorbs energy, the reaction is endothermic and takes in heat, or more formally, heat is transferred from the surroundings to the system and the temperature of the surroundings falls. Conversely, if the enthalpy of reaction is negative, the system releases energy. The reaction is exothermic and gives out heat, or more formally, heat is transferred from the system to the surroundings and the temperature of the surroundings increases. Enthalpy is one of the most fundamental concepts in thermodynamics, and given that most of the chemistry we do is on an open bench at constant pressure, it makes much more sense to consider enthalpies of reaction rather than internal energies of reaction. It is a concept most of you are already familiar with, but I hope you have more of an idea of the relationship between it and other thermodynamic concepts. If you have any questions about this or any other video, please do not hesitate to contact me.